paper back there in that pink basket. Okay, since this is a 2-day lesson, we're just going to go ahead and do a couple examples today, let you work on your homework, and we'll finish out the examples tomorrow. It is not a difficult concept. It just sometimes takes a little bit of time. So the example that we're starting with is y equals x squared plus 4x plus 5. When we want to graph a quadratic, the first thing we need to find is our line of symmetry. This can also be called the axis of symmetry. This is the line on the graph that if I were to fold my graph in half across this line, the left and the right side would match perfectly.
Is that a 1 in that box?
Yeah, like step number 1. This line of symmetry is found by doing x equals negative b over 2a, where the a and the b come from the quadratic, just like if we were doing the quadratic formula. So in this specific example, my a value is 1 because there's no number in front of the x squared, so we assume it's a 1. My b value is 4, and we don't need it, but my c value would be 5. Plugging that into my line of symmetry equation, I have negative 4 over 2 times my a value of 1. 2 times 1 is 2. Negative 4 divided by 2 is negative 2. This is the first thing that I put down on my graph. So I go to negative 2 and I draw a vertical dotted line, indicating that the left side is going to be symmetric to the right side. Yes, always a dotted line. It just so happens that this line of symmetry is also the x-coordinate of the vertex of my parabola, which is the highest or the lowest point. So I still need to find the y value. In order to find that y value, I need to take negative 2, plug it back in for x, and simplify. So I'm going to have negative 2 squared plus 4 times the negative 2 plus 5. Negative 2 squared is 4. 4 times the negative 2 is negative 8. 4 minus 8 is negative 4, plus 5 is 1. So then my vertex is the point negative 2, 1. So then I go to negative 2 and positive 1, and I put a dot. That is the first point that we put on our graph.
Points, we're like, yeah, we get a day off.
In order to properly graph a quadratic, we need 5 points in total. We have 1, we need 4 more, but I think Grant just figured it out. Because we have a line of symmetry, that doesn't mean we need to find 4 brand new points. We could find 2 on the left side and then find their matches on the right side without doing any extra work. So that's the beauty of having something that's symmetric across a line. To find these extra points, we just go ahead and do an XY table. So that's step 3. When we do our XY table, I always pick numbers that are extremely close to my line of symmetry. So because my line of symmetry was 2 or negative 2, I'm going to use negative 1 and 0 because those are really easy numbers to plug in. So I go ahead and I substitute these values in for the x, and I simplify. So when I plug in negative 1 squared is just 1. 4 times a negative 1 is negative 4. And then we have the plus 5. 1 minus 4 is negative 3. Plus 5 is positive 2. I do the same thing with my 0. 0 squared is 0. Plus 4 times 0, which is 0. Plus 5. And 0 and 5 give me 5. So I now have 2 points that I can use. The first one is negative 1, 2. Zoom in. Because this is a line of symmetry, every point over here will have a match on the other side in the same place. So this point is 1 step away from my line of symmetry on the right. So I go 1 step over on the left, and I have found its match. So now I have 3 points, and I just need 2 more. When I plugged in 0, I got positive 5. So I go to 0, 5, and I put a point. This point is 2 steps away from my line of symmetry on the right. So I go 2 steps away on the left, and I draw its matching point. Now I have 5 points, and I can draw my parabola. And then we're done.
Have we already done this?
Should have done this somewhere, yeah.
Okay, because we've done like that.
Yeah. How do we feel about that? Easy, hard? It's really only 3 steps, yep. Anybody have any major issues with this? No? Okay, let's do another one. So this time I would like to use the quadratic. Negative 2x squared minus 12x minus 14 Cole, what's my first step?
You have to get your line of symmetry.
Yep. And what do I use for that line of symmetry?
It should look like x equals. Will it still be negative b over that?
Yeah, it's always going to be negative b over 2a. So then I just go ahead and I plug in my a and my b values. My b value here is already a negative. So I just take the negative of negative 12 where a double negative becomes positive. So this becomes positive 12 on the top. And then 2 times my a value of negative 2 is negative 4. And then I go ahead and I reduce that. 12 divided by negative 4 is negative 3. So my line of symmetry exists at negative 3 on the x-axis. It's always the first thing I put on my graph. I also know that this is the x-coordinate for my vertex. Vertex being the highest or the lowest point on the graph. How do I find the y-coordinate for that vertex? What do I do with the negative 3, Brandon? We plug it in for x and solve. So I do that, and I get negative 2 times negative 3 squared minus 12 times negative 3 minus 14. We do the negative 3 squared first, which becomes a positive 9, times the negative 2 is negative 18. Negative 12 and negative 3 becomes positive 36. Minus 14 will give me 4. So negative 3, 4 is my vertex, and that's the first point that I put down. How many points do I need in total to be finished with this graph? 5. Does that mean I need to find 4 brand new points from here? No, I could find 2 on one side of my line of symmetry and then find 2 matches on the other side. How do I find these 2 points that I need, Colton? Do I just make them up, or do I find values that are close to something? Numbers that are directly next to my line of symmetry. My line of symmetry is -3. So I could do -2 and -1, or I could do -4 and -5. I find it easier to plug in smaller numbers that are close to 0. For some reason, they just work out a lot easier. So I'm going to use -2 and -1. So I'm just going to go ahead and do an XY table. Plugging in -2 and -1. So when I plug in -2, I get -2 times -2 squared minus 12 times a -2 minus 14. We simplify it out. -2 squared is 4 times -2 is -8. -2 and a -12 is a positive 24. And then minus 14 leaves me with a positive 2. So -2, positive 2 is my next point. And then we find its match on the other side of the line of symmetry. And then I go ahead and plug in -1. -1 squared is 1 times a -2 is -2. -12 times a -1 is positive 12. And then minus 14, which leaves me with what? -4. So then I go to -1, -4. And I find its match on the other side. Then I have 5 points. And I can draw my parabola. Anybody super duper confused? I have a question. I've now done 2 examples. I've now done 2 examples. This one, where it opened up, and this one where it opened down. I can't zoom out anymore. How do I know which way it's going to open before I even graph it? What do you mean by the first point, Ebony?
Like the first point that you find.
Nope. Say it, Eli. If what is positive or negative? Grant. The A term. So that first number in front of my squared, if it's positive, like in this example, where it was a positive 1, my parabola opened up like a cup. But in this example, where it was a -2, my parabola opened down like a frown. While this is not innately helpful, if I'm graphing it and I have a negative value here, but my parabola is going up, I've done something wrong. It is an indicator to me of whether I'm working in the correct direction or in the wrong direction. Okay, so it's a good self-check. It's also a wonderful test question, like, hey, how, without graphing, identify the direction of opening for this parabola? That just means it's opening up like a cup or down like a frown. There you go. Okay. I really am curious how many of you already feel really good about this? Just out of curiosity. We're going to do at least one more. And by one more, I mean you're going to do it.
Just let me plug it in. It's really all of it.
It's really just plugging in, yeah. It's nothing super crazy. And then it sounds like Colton's going to be the one doing it for us on the board. I think it does.
I'm trying to go with this, but I'm kind of confused on
I pick an x value close to my line of symmetry. So here my line of symmetry was -3. So I picked -2 and -1 because they're directly next to it. And then I just plugged them in for x and solved. Very similar to how I did the vertex part.
Okay.
Okay, So let's go ahead and do, find a good one. A little sad. Yeah.
So I know which do we have?
They're all grouped. So it's all unit 4. I'm trying to remember. I think we started. Yeah, so I believe it starts with like distance between points. It might start there. Yeah, I'm pretty sure it starts with distance between points. Yeah. No, I always just do the unit that we're in. Okay, kiddos, this is the one I'd like for you to do. Y equals x squared plus 4x plus 6. Graph this completely, please. Show of hands who's finished. Here's a couple more. No, there's a couple. Oh. Mr. McIntyre, you're up first.
For this,
Yes, please go up and accomplish the first step. In graphing quadratics.
just the first step.
Just the first step, huh? Good, that's the one you're gonna do. Yeah, you are. It'll be fine.
Do I gotta click on anything? Do I just-
You should just do it right. Oh, so we just go directly next, right from the line symmetry and figuring out the point. Right.
This part right or no?
Okay, did you do that part correct? So far, finish it out.
I gotta finish it out.
Yeah.
I think it's the same answer as the other one, because maybe we did something that was just exactly. that.
It is -2, yes. Okay, so now you may sit. Mr. Bailey, step number 2.
I tried basing like the problem off the first one. The whole first part of the
And that happens a lot of times we'll have similar lines to symmetry, am I correct? Okay, cool. So are you confused about how like we're picking numbers to plug in or how we're plugging it? Okay, so you know where your line of symmetry is?
Yeah.
Okay, I just picked the x value that was next to it. So if it was at -2, I picked -1, and then I plugged -1 into the function for x. And got an answer, and then that was the point that I got. Okay, so what did it come out to be?
I got all that was.
Okay, so then what did you just find in that second step? We found what specific point on our graph?
Why?
No, what do we call that point?
Oh, I don't know. It's
Eli, what do we call that point that he just found?
that
Step number 2.
first next one.
It's the first point that we graphed. But what do we call that point? It's very specific, it's very important. The vertex. It's either the highest or the lowest point on the graph. So write the point that we just found, -2, comma 2 in parentheses, Brandon. There you go. So that point has to be somewhere on your answer sheet as you're doing this. Carly, go up and graph those first 2 things that we found. Go ahead and graph those first 2 things, the line of symmetry and the vertex.
Is that -2 from like something, and then we got 2 on the bottom?
So when we plugged -2 in, yes. Perfect. Is this parabola going to open up or down?
Up.
Up. How did you know?
What is it? It's the A is positive.
A is positive. Okay, Mr. Pfeiffer, you're up.
Hold up.
Okay, I'll give you a second.
Hold up there.
Yeah, but that's not the problem. I can't get there if I can't even get the -2 out.
Okay, so I plugged in -2, give me this one. And I plugged in -1, give me this one.
We're getting faster than this.
Well, I wouldn't put in the positive one, because that's the far away. We always do the two next to it because, quadratic graphs move really quickly. So we do the two that are closest to our line of symmetry. And the farther out than that, I think they're. Hey, Brandon, what are you talking about? Of all things. Okay, Kaylee, go ahead and do it, please. Yeah, we always do the X value directly next to it. So you're on step number 3, finding the next point.
Okay.
This is confusing me, I'm like,
I can see about
Okay,
five.
so step number 3, you have no idea what you're doing.
not really.
Okay, Grant, you're up. So I think we put that conversation somewhere. The 2 new points are in round, and they're matching. You have to, yeah, you have to show the work together.
Oh, come on.
I know, end of the world. You
Let's
got
use
halfway
this.
forward when you do that?
Yeah.
So you plug in -1, right? You got 1. Okay, and then we plug in 0. Uh-huh. Okay, pay attention to this and what Grant is doing, because we need 4 more points to graph this parabola. That was pretty good. Does that make more sense? Okay.
But that's not.
Okay, so once we graph this point, this is where I pick the 2 numbers that are directly.
Forget how to do the rest of it. I did it, but I forget how to do it.
We want directly next door, so we basically want its neighbor. Because if I pick something over here, I can't guarantee it's directly. Yes, yep, that makes more sense.
Not to figure out the best way. It's just one of those.
Yeah. I'm watching. I'm watching. Okay, so what X values did you plug in, Grant?
-1 and 0.
Why'd you pick -1 and 0?
Wrote it on the wrong side.
No, I'm not saying it's wrong, I'm asking.
No, because it's closer to 0.
Okay, so it's the 2 points that are directly next to my line of symmetry, correct?
Yeah.
So then you just plug those into the function, and when you plugged in -1, you should have gotten 3.
Yeah.
And when you plugged in 0, you should have gotten 6.
Yeah.
Right? Okay, plot those 2 points. I see one of them up already. Keely, does that make sense why we picked -1 and 0?
Yeah.
Okay, and then we just plug them in. There's no wrong, like, you don't have to pick those 2, but if I go too far away from my line of symmetry, I can't guarantee they're gonna fit on my graph. So we try to do the ones that are super close, the way they're most likely going to fit.
Okay.
So if you wanted to do 12 and 17, go for it. There could be huge numbers, you could go for it if you wanted to, okay? I would never count off for picking different numbers. Okay, how did you find the 2 on the left-hand side if I just plug in X values there?
It's symmetrical.
It's symmetrical. So I just found the points in the matching position on the opposite side of the line of symmetry, right, Brandon?
Can I sit down?
Okay, you can sit down now. And the last step, of course, would just be to connect all of your dots and drawing the parabola. Who is confused about any of this process? It is perfectly fine if you are. Is it starting to kind of make sense? I know some of you struggle with like, which X values do I plug in for the third part? Why do I plug those in? If you didn't want to plug in the ones directly next to it, that's fine. However, I can't guarantee they're going to fit on your graph. So we plug in those that are close because they're most likely to fit. Parabolic equations grow very quickly. Okay? What? It is. It's exactly like a virus, pretty much. Okay, so I'm going to go ahead and give you your homework. You do not have to do all of them, but I expect that you will do at least half of them today. Because you should be able to. Okay? And then tomorrow we'll do some special cases. Oh, you're so excited. I see you on your phone there, yeah.
Oh,
It probably doesn't work that well on here anyway.
Yeah.
The beauty of it. new buildings. I will say, I think that's a perk.
It ain't gonna be a perfect.
Oh, it'll be a hot
We can't even call the cops.
That's, we do have a classroom phone, and my phone works in here. But, does it? That's good. And like, if something were to happen, we just need a battery ran through one of the walls, and we should be fine. Well, so I have those two closets, and all they did was they put up drywall, and there's no lockers on the outside of that closet.
Also, I definitely feel like I could jump through one of these.
Oh yeah, no, you totally could. You might have to work a little harder because the drywall now, but you should be fine.
We're probably busting through that wall like Kool-Aid Man.
Okay, kiddos, you are just working on the homework now. If you have questions, of course, I will stay on the call and just let me know.
Well, I got